you're still catching up with IPv4, so I don't want to add IPv6 here and confuse things.
Okay.
So let's go for a couple of sessions in IPv4 related topics. And then once you're okay with this, uh, once you're okay with that IPv4 part understanding, then we can jump into IPv6. It's a small topic, but yeah, I don't want to break the knowledge built for IPv4.
Okay.
You're able to see my screen?
Yes.
So the next topic is so we are skipping IPv6 and wireless in the first module. So that is kind of a little advanced compared to the topics we are going through. So I just go to the basics 1.12, which is explaining virtualization fundamentals. Again, we will see this topic only once in the CCNA concept. So if you have any doubt, just please ask me. Otherwise, we won't be able to see it again.
Okay.
So this is virtualization. Have you heard about virtualization? Like servers, networks.
Um, I have some idea wherein what we do is we run multiple operating systems in one system, something like that.
Sorry, I didn't get you. Can you come again?
Like running multiple operating system in one system, is that virtualization?
Uh, Running kind of that is kind of inclined towards virtualization, but that is not exact virtualization. What happens is, so you get a server, right? That's a powerful server, but inside that server you will run more than one machine virtually,
Okay.
right? So what happens is you might be running Linux. So you have a Linux server, yeah, Ubuntu server. Okay, so it is a box. So inside this, you will run many machines.
Okay.
It can be a Cisco router. I'm saying an example because the Cisco OS should be compatible with the Linux OS here. So Linux OS is a OS which is built with the server, right? Built in with the server, and then you will run many machines. It could be a Juniper router. So Juniper uses Linux Ubuntu 18.4 or latest Ubuntu version, so that this might be compatible with the underlying server, and then you might say some other Palo Alto, right? So you can run these many virtual machines inside the same server. So this reduces rack space. So you have only one machine physically, but internally you run multiple virtual machines inside. Rack space, cost of buying the physical devices, right? You just need the OS. You don't need any physical devices anymore. And field technicians, right? So if you're buying a new machine, you would have to install it to the site, so you would have to send a field technician. The time and the cost involved with the field technician, right? You cannot just simply send a field technician. You have to book a schedule and then send him along with the device, and he should go with the proper tools, everything to rack and mount the device, and then install. It involves a lot of time. So administrator needs all these things. So with server virtualization, you don't need to do this. You install one physical server on one of the rack, and then that's it. Once you get the remote access, You can move in the software required for these virtual machines, and then just bring up these virtual machines into them.
So one physical hardware and multiple virtual machines.
Right. So currently people are like using it. I'm not sure how far the enterprise have moved. Uh, but yeah, so when you go to cloud engineering, this is the concept. So you're going for a AWS, Azure, Google Cloud, right? So this is what they're using, virtualization. So they will just give you options to create the machines as well. You don't have to send anybody to back up the machine on the AWS data center anywhere. So everything is uh, ready. So you just have to go and spin up the virtual machines as you require. So that is AWS, like public cloud providers. Uh, Internally also you can use it, like you can bring up a server and install it in the data center of your interest, and then run the virtual machines yourself and then connect it to the internet. Okay?
Okay.
What, you are not able to connect dots?
Yeah, I'm getting some idea. Like instead of having multiple machines running multiple physical machines running multiple softwares, we are
Hmm.
trying to just make sure that one machine is used for creating the software itself, for running the software itself.
Running multiple virtual machines.
Okay.
Okay. So it doesn't have to be like same vendor. Like if you are running a physical server, uh, it's not like you always run a Juniper only. Once you have started with Juniper device, right? So you can use any vendor devices which are compatible with the underlying OS of the server. Okay. So the next thing is containers.
And if we are talking about where virtualization is useful, mostly for data centers, right?
I won't say data centers. It is used mostly on the enterprise, right? So what would happen is, if you're using this physical server, right, it is going to come with some CPU, right? Let's say 32 core CPU, right, and then 32 gig RAM. So what happens is, when you keep building virtual machines, these resources, like CPU and RAM, will be shared across the virtual machines. So in that case, data center, you cannot predict the traffic. Like it will be using high amount of traffic. I mean, it will be servicing. It will be servicing high amount of traffic, right? So you will go with, when you are going to go with the virtual machines, then uh, it's going to create a situation where you have to buy a very powerful server, and then you have to limit your virtual machines inside the physical server so as to service such high amount of traffic. Correct. So where it will be used is, it will be installed in a data center, right? But it will be used with the enterprise users, not data center kind of service. Like enterprise means I'm talking about normal site, like site with 10 people, 12 people.
Okay.
Okay. So it will be used in data center, but it's not for a data center purpose, because the number of as you increase the number of virtual VMs, right? Your resources will be shared among the virtual VMs. Then the performance will be slower compared to the actual physical device, because it's sharing the resources. So all the VMs will exhibit slow performance as you start increasing the number of VM count. So that would be a problem.
Okay.
Okay. So AWS does the same purpose. So in the AWS, I mean cloud, right? The AWS or Azure, Google Cloud, they will give you access like multiple regions. So in multiple, they have divided their cloud infrastructure into multiple regions. So if you are belonging to US East, US West, US North, US South, so depending upon the area, you can go and create the virtual machines, like it can be a server or it can be a firewall, yeah, and route your traffic to the cloud device, whichever it is, the router, firewall, whatever, and then from there you break it to the internet.
Okay.
There is no problem with when you are going for a AWS based cloud devices, because resources wise you won't find any uh, inefficiency. But the problem is when you are going to AWS and send more traffic, you will be charged according to the amount of data used. So you need to worry about the cost part. But when you are having your physical server deployed yourself on your own data center, the cost won't be, I mean, you won't be charged monthly, weekly, daily for the amount of data that you use. But uh, that's what there is a there is a limitation on the resources. So you should be aware of your resources, how much your virtual machines can handle before it breaks due to some high amount of data. But with AWS, you don't have such AWS, the other cloud providers, you don't have such limitation with their performance or the resources. But you have to pay accordingly to your usage. So it might be high or low depending upon your usage.
Okay.
The enterprise nowadays, like cloud, they are moving towards uh, cloud only. Like they'll have at least 50% of their network is in the cloud. Then okay.
Hmm.
The next concept is container. So now I told you about physical server, right? So
Yes.
physical server creating virtual machines. Uh, Again, the container concept also falls into the same, but in the physical server, I told you about the underlying Linux OS, correct? So if you are using the Linux in the physical server, if you are using Linux OS, and the VMs should also be using the same flavor, correct? It doesn't have to be exactly Linux OS, but some flavor of Linux, like Ubuntu and some other flavors of Linux. So Linux has some 5 flavors, I guess. So it has to be one of them. Then only it can support. But container is a orchestration technology, right? Container. Okay. So container is also kind of a visualization, but it is independent of your underlying OS. So here you can use Microsoft Windows, the container, and then you can use uh, Cisco device, Cisco IOS, and then you can use Palo Alto Firewall, right? So the only difference between container and the virtualization, server virtualization is, so with the server virtualization, when you are using a same physical machine, the VMs that you build on inside this physical server should be one of the flavors of Linux. But with container, when you're going with the container technology, you can still build machines, but they are independent of your underlying Linux OS. So it doesn't have to have the touch base towards the underlying OS, which it is supported by the physical hardware. So when you're going with container technology, the machine boot up, right?
Yes.
Uh, it takes very less time compared to the physical VM. I mean physical servers VM. Okay, and it is mostly this container technology, right? When you say server virtualization is mostly towards networking side. Okay, but this container stuff, right, mostly used by the developers, right? So what happens is when the developers are developing applications, right? Yeah, the container, it can be a virtual machine, it can be an application, right? Container is mostly towards building an application, right? So they build an application, it has to be compatible with the environment. For example, what happens is this, let's say, the developer developed an application in a Mac OS, right? Or in a Linux, or in a Windows, right? all his unification. Finally, he will move it to the testing or QA environment. Okay, so
Sorry,
the
your
QA
voice
environment will be
was
on Windows. Yeah.
disconnected for some time. I can hear you now properly.
Okay, can you hear me now?
Yeah,
Is it clear now?
correct.
Clear?
Yeah, clear.
Okay. So container, right? Container technology is mostly used by the app developers. Okay. So what these guys do is they'll develop an application, right? And consider they are developing it in a MacBook, and then they are moving it to a QA environment which is built in Windows, right? Then there will be compatibility. Certain things which are working when the developer developed in his MacBook won't be working in the Windows because of compatibility issues with the underlying OS. But when you are going to deploy your application in container, you do not have to worry about what would be your underlying infrastructure, whether it's a Windows-based OS or Linux-based OS or Mac-based OS. So containers are independent, so it acts like a package, and you don't have to worry about your underlying infrastructure. Clear? So
Okay.
these things would be very much understandable uh, when you see that in practical time, real time environment. Otherwise, it would look little unclear, like where these dots join together. But just understand, like this container and virtualization are creating logical machines. Yes, one is dependent on underlying OS, other one is independent of uh, underlying physical OS.
Okay, got it.
Okay, so the next one is VR. Okay, so virtual routing forwarding, forwarding or forwarder, whatever. So you have a router, right? So in the router, I told you about routing table. You remember?
Yes.
So it has one routing table. In general, you buy a physical router Cisco device, and you have one router, and inside the router, in generally, just a routing table. Right? We can call it as global routing table. Okay? Global routing table. Global means there is only one entry. That's what I'm trying to mean by global routing table. But that is not enough for the recent technology. For example, we are using MPLS, correct? So there is one technology called MPLS. So in the MPLS, at the end of the day, you might have customer one, customer two, customer three, customer four, right? This is the PE router. Okay, yes, customer one, customer two, customer three, customer four. So you see, uh, all these guys are connecting to one provider, which can be Verizon. Verizon. So this Verizon guy has one router but allows multiple devices to connect. So when these devices connect to the provider, they will have to share their routes or prefixes to Verizon, right? And it is done by each one of the customers. So when these guys do, for example, I said this guy can use same 192.168.1.0/24, right? So same 192.160 can be used by this person, this person, this person in their LAN, correct? You cannot restrict them from using this subnet on their LAN, correct? It's a private network, right?
Yes.
So when these guys are going to use their private network and connect to the PE, it will create a confusion on the routing table, right? Everyone shares the same network, correct? So that's when Verizon the PE is going to use VRF. So what he will do is he will divide the routing table into number of customers equal to number of customers. So VRF1, VRF2, VRF3, VRF4. Okay. He will divide a routing table into multiple routing tables and give them individual name and dedicate it to a specific customer. So whenever a customer shares same 180 to 168, it will go to the VRF1 table, but other routing table have no visibility towards this VRF1. So VRF2 doesn't have visibility to VRF1. VRF2 doesn't have visibility to VRF3 and 4 as such. So in this way, it won't create confusion as it's going to maintain different routing table. So without VRF, you have only one routing table, which is global routing table, and every route shared is going to be in the same pool, and it will create confusion who shared what prefix because all of them look similar. Yeah.
Okay.
So virtual routing forwarding. So again, it is a basic concept. If you go at CCI level only, you would see some lab and theories based on virtual routing and forwarding. But for now, why it is given in the CCI syllabus is when you are going to be an L1 engineer, still you have to do a monitoring of the networks. So in the during the monitoring, so it's not just monitoring. You would go into the device and you pick the initial logs, some alarm logs, some problematic logs. So when you are going to that, you would still be exposed to the VRF in the enterprise networking. So you should be aware of the word VRF. So for example, if you remember, right, in the Windows OS, I did ping 1.1.1, right, like this. Correct.
Yes.
Do you remember this command? So in this command, I did not mention anything. So basically, you would need to mention which routing table that you want to use to initiate this ping towards this destination. So since there is only one routing table and it's a global routing table, there was no need to mention this. But if you are going to an environment which has VRF, right, you need to mention if you are trying to ping any IP address, make sure you mention the VRF, okay, routing instance and the VRF name. So you have to mention from which VRF you want to initiate this routing because from one VRF this may not be one routing table, this is not reachable. In another routing instance, it might be reachable because the other router is not aware of this prefix. So same physical router, but multiple routing tables. So one routing table may not have access to 1.1.1. Other guy may have access to the 1.1.1. So you are aware that which VRF have access to a specific prefix. So when you are trying to do a troubleshooting and try to ping any of the IP address belonging to any of the VRF, you have to specifically mention which VRF. Otherwise, if you do this, it will just fail the ping command. So as a L1 engineer, you would need to do all this ping, trace route, right? So in that case, you would have to encounter this VRF stuff. So you just be aware that VRF creates multiple routing tables that which does not mix up with other routing tables and global routing tables. So it is like a private routing table inside one physical router.
Okay.
Okay. So next one is switching concepts. Mac learning and easy. Okay. So MAC means I'm talking about the MAC address, correct? So how it's going to learn and how long it's going to keep it in the table. So consider you have a switch, right? Okay. So you have one PC, another PC, one, two. MAC table will have interface MAC address. So this will be the entries in the MAC table. Okay. The interface name is, let's say, fast Ethernet 0/1, fast 0/2. Okay.
FA
So
you
when
right? Fast Ethernet.
fast
FE?
Ethernet, FA means fast Ethernet. Okay. Fast Ethernet.
Fast Ethernet. Okay.
Okay. Without FA, if I mention E, it is just Ethernet. And if you see gig, then it means giga Ethernet. Gig means it supports 10,000 megabits, which is 1 gig. And then you have 10 gig, so 10 giga Ethernet, 10 GB. Okay. So when you're trying to initiate a ping, right? Ping to this IP address. Let's say this guy's IP address is 2.2.2. This guy IP is 1.1.1. Okay. And initiating a ping towards this IP address, right? So the packet would have to go this way and then come this way. Correct. So when the packet is going to be sent to this interface, and when the switch receives this packet, he will take down his IP address. Consider his MAC address is BBB. Okay. So when the packet comes here, received on this port, the switch will note down. Okay, I received packet on FA0/1. The MAC address A. Okay, it has created an entry. And similarly, when B is going to respond back, right, he is going to respond back with a reply. So now again it will note it down. Okay, I received one packet on FA02.
But what
Hmm?
if it doesn't know where is B? Where is number
That's
two?
what. That is the next concept. The next concept here, if it doesn't know, it will do a MAC flooding.
Okay.
It will send it to everybody else. Right? So whenever a packet comes here, that's how the MAC table is built. So MAC learning, how the MAC learning happens. When a packet comes to the port, the port note downs what is the MAC address of the packet received on that port, source MAC address. And then,
But for the first
hmm,
device to send a packet to switch, the switch should have known device number one, right? How did it know device number one?
sorry, what was the question?
So for the switch to send the request to device number one, first
Hmm.
the switch should learn about device number one, right? How did it learn about device number one?
See, I just broke communication here and explain how the MAC learning happens, right? So when you want to see the whole picture, when you send the packet to the switch, right, the switch receives the packet from A and sends to everybody else, right, on the switch. There might be three, four, five pieces, right? So one would mention the destination IP. You initiate a ping, right? 1 2.2.2. So the destination IP is already aware, and it's not known the MAC address of B. It doesn't know the MAC address of B. So the packet, when the MAC address is not known, in the destination MAC address field, you will enter this value FFA. It means send it to everyone else and allow the correct person having the MAC IP address 2.2.2 to respond. So 2.2.2 will respond back to A using the source IP and source map of A, right? So when the packet is sent, just a minute. So let's say, see, you are initiating a ping, right? So when you initiate a ping, what are all the information that you have? Source MAC, source IP, right? Destination MAC, destination IP. Correct. The source MAC could be, so when you are initiating a ping from a machine, so the machine will construct the source MAC as AAA, correct?
Yes.
And the source IP is 1.1.1 because you are in the local machine is aware of its own detail. Correct. Now the second question is how you are going to let first machine know about second device, vice versa. Correct. So we will see how second device learns about coming back to one. But let's finish up how first device is going to learn and start constructing detail about device 2. So destination MAC, I'm not aware, right? I'm not aware. So I will put FFFF. Okay? FFF means the last address of the MAC. Right? MAC is a hexadecimal format address. So FFF is the last address of a MAC addressing configuration. Right? And then destination IP is you already gave it in the ping command 2.2.2.2. Correct. So you already let your local machine that you want to go to this destination. So destination IP is built. The only missing piece of information is destination MAC. I don't know the MAC address of the second device. So what would happen is this device, the PC1 will send the traffic, the packet to the switch. Now the switch will look into the MAC address table and see it is FFFF. So when you see FFFF, then it means the switch has to send this traffic to everyone else with these three available information. 2222, source MAC AAA, source IP 1.1.1. So when the packet goes to the switch, it sees FF and it will be sent across everyone. And when device 2 receives the frame or a packet, let's say frame, okay, because we are still in L2, let's say frame, and then it sees the IP address 2.2.2. Correct. So when it sees the destination IP as 2.2.2 in the IP field, it's going to respond back saying, okay, somebody is trying to speak to me because I see my IP address in the destination field, so I need to respond back. Clear?
Yeah.
So during this process of receiving and sending the packet, whenever the traffic hits the port, either from machine 1 to switch or machine 2 to switch, the switch will note down who sent that packet. Okay? So when this machine 2 responds back, it's going to say, okay, machine 2 is lying on port FA02 and machine 1 is lying on port FA01. Clear?
Yeah.
Okay. So this is how MAC learning happens. Okay, MAC learning. So how long these entries are kept here? Next time when the packet comes to switch to, sorry, device 2, it won't do that flooding. It won't use a destination MAC FFFF. Clear?
Okay.
Because it has learned it. So it has found that during the response and request, it has learned the MAC. So now it's going to simply send it to unicast. It will send it to the respective port. When the packet comes to the switch will send it to FA02 device, and similarly from device 2 to device 1, it will use the port FA0/1. But how long it's going to keep this entry? Which of no use. You may have, when it is 4-5 PCs, it is fine. You can keep this entries indefinitely in the MAC table. It's not going to cost you anything. But when there are hundreds of thousands of PCs, right? How many entries it can keep it in the MAC table? So just to maintain some relief on the MAC table, uh, just removing useless entries, the MAC caging time is 300 seconds.
So what does it
300.
mean? Still 300 seconds it remembers the devices?
As long as it's not used. So if you have not used this entry, like you have not sent any traffic to this entry for this 300 seconds, then it will be removed. Then you have to redo the same process if the communication is going to happen in the 6th or 7th minute. So if you are going to use it, consider at the 4th minute you send some frames that is going to match this entry, use this entry in the map table, then the timer would be reset to 0. And then it will go until 5 minutes without no use, I mean, without use. But if you don't see any frame for the 0 to 5th minute, then it will be scrapped off.
Okay. So basically for 300 seconds if the interface is not has not sent any frames, then it will forget the entry in the MAC table.
About the PC. So you see, it is not the interface MAC address, right? You remember, because what people do is when they are studying CCNA, they'll it will look good everything, but when they go to production, right, they'll see interface MAC address in the entry or in the MAC address table, right? You see, right? There will be two portions. Okay, let me just erase this. So you would see if you give show MAC table command to MAC table command, you would see two entries. One is interface, whatever is interface map, and then state. Uh, let's see state interface. Okay, you see interface fa0/1, fa0/1 after the uh, static. Similarly, you would see one more entry for the same interface 0/1, MAC address ZZZZ, and then dynamic. Okay. So when you see an entry dynamic, it means it learned the MAC address, and this entry is the host MAC address. Any host which is connected to this interface. And if you see a static entry and says the MAC address, it means the actual interface MAC address. Yeah. So dynamic means using this name, the meaning you can understand. Dynamic means it's not something hard coded, it's not something already present. It's learnt on the way. Dynamic keeps changing. It's not something which is permanent.
So that is
Correct.
dynamic MAC address and static MAC address, right? Two types of MAC
Correct.
address.
Static means permanent, doesn't change. So that would be implied to the actual MAC address of the interface. As long as the interface exists, this is the MAC address, right? So tomorrow, consider you have host one, laptop one. So you and your friend, right? So you and your friend. So tomorrow, today you connected your cable to the switch port, right? The switch will learn your MAC address, etc. So you disconnected it today, and then tomorrow your colleague comes. He comes and uses connect the cable to the same FA0/1 in the switch. His MAC address is YYYY. So this will keep changing from ZZZ today to YYY tomorrow. But the static portion, right, the actual MAC address FA0/1 of that port will remain the same, irrespective of who connects the cable to the. It can be a printer machine, it can be IP phone, it can be a laptop, it can be a PC, whatever. But the static MAC address implies the physical ports MAC address of the switch, and dynamic includes the MAC addresses learnt by the switch on this port by the end host connector. Sorry, of the end host connector. Any questions?
Sorry, I didn't understand static and dynamic.
Okay. Oh, let me go in this. So let's say this much. Okay.
We are talking about static and dynamic MAC address.
Correct. No, no, static and dynamic MAC address only, but
Yeah, there's
how
static
the
and
MAC
dynamic
address?
MAC address, right?
Yes.
Okay.
So let's say this is the FA0/1 port. Correct. So this port has one MAC address, correct? The port itself,
Okay.
right? I told you every port in any machine has a MAC address. See, I gave an example, mobile phone. If you have two SIM cards, you get two IMEI numbers. One SIM card, one IMEI number. Right? So similarly, if a switch has 12 ports, there will be 12 MAC address associated, right, with each port. One
Okay.
port has one MAC address, correct? That is
Okay.
permanent, right? You know the MAC address are permanent, right?
Yes.
The ports have the MAC address,
And they
the
never
just
change.
for
And they
internet
never change.
application. They
And they
never
never
change.
change.
Correct.
It is associated with that one.
Correct. Now you have one PC. Correct. Right, PC one. This also has one internet, right? This has one interface card, right? Which you will connect. This is one port, correct, on the PC, where you will connect the cable,
Yes.
correct? So when you have one interface card, we call it as network interface card, where you can connect the internet cable. Then this port also supposed to have one MAC address, correct? That's it.
Yes.
When you connect the cable, it looks like this, correct?
Correct.
Now the switch has to maintain two entries in the MAC table. Correct? So I go to the MAC table of the switch. I gave show to MAC table. Okay. Has interface MAC and state. Okay. What a switch will do is first it will list down all the ports and its MAC address and its state. So it will say FE0/1. The MAC address is A and it is static. It's not going to change, always permanent. Okay.
Yes.
Similarly, if you have one more port, FA0/2, it will say FA0/2 BBBBB static. Okay. Now I'm going to bring in one cable and connect port FA0/1 with the PC1.
Correct.
Now switch is going to learn I have someone who is connected on FA0/1 whose MAC address is ZZZ and I learned it dynamically.
Okay.
Right? This is used to understand, for example, tomorrow one user says I'm not able to access the internet. Right? The first thing that you would do, apart from checking anything on his own PC, right? As a network administrator, you don't focus on the user PC initially, but you will focus on the networking PC, whether it is a switch or router. So when you have to start from the bottom, you have to start from the switch. So the first thing you will check in the switch is, okay, let me go to the switch and see if that person's MAC address is learnt in the switch or not. If I don't see his MAC address, if I don't see his MAC address here in the MAC table, then this person's packet has not reached. It is dropped somewhere here itself. Because if that person had reached this far, I would see his MAC entry here. If I don't see his MAC entry here, at least for the last 5 minutes, this person had not sent any packet here. So the first indication you have to check is whether this person has reached the switch or not by using this command show MAC and check his MAC address is present in the dynamic of this body. So you would understand that this person, even if you do not know, for example, even if you do not know to which port in the switch this person is connected to, right? You can ask his MAC address, hey, give me your MAC address from your PC. Then you go to the switch and show MAC table and filter with his MAC address. Then if that person has really sent any traffic to the switch and it is not going to access it, I mean he was not able to access the internet, then at least you would see an entry here using the MAC address filter, this filter, and see which port he is connected to. If you understand which port he is connected to, then you can learn about his VLAN information. Okay, we will see that in the future sessions about how VLANs and all used. So once you get his port details, you will get to know more information from the switch side for this user. So this table forms the basis when you are troubleshooting something for a user, right? So what would happen is initially, right, when I was a new engineer, so there won't be any entry here. Okay. And when my senior asks me to get this information and confirm me whether this Mac has seen or not, so I would go to the Mac table and I would see there will be so many entries for FA0/1, right? So, I mean, some packet would be coming from this direction, right, from other hosts here, and from here, right. So this port will maintain a Mac table entry for many sources. I would get confused and see, "Hey, what is it? First of all, I don't understand what was static and what was dynamic, and then I saw more entries in the dynamic side, and then I get confused really for a long time. And then after 6 months or so, then I try to understand, okay, this, because when you're practicing the Cisco packet tracer, you have only one or two hosts, so it's very easy because you built it, so you easily understand what is the MAC address of each field. But when you go to a production network, you would see more entries. So that's when you get confused, like what I'm trying to locate, which PC I'm trying to locate. That's the confusion. Understand this fields of different static and dynamic, then next things out. Is my voice not clear?
Uh, a bit clear, but some disturbance is there, like n- some static noise, some fan, I think.
Oh,
Yeah, it's fine now. I put headphones.
okay. Okay, you got the point?
Yeah.
And then frame switching and frame flooding. So flooding means, I just explained, right? Flooding when you have an entry of F the destination MAC address.
Sorry, your voice was being uh, disconnected. Now I think better.
Okay, one second. Is it clear now?
Yeah, clear.
So there is one concept called frame flooding. Okay, frame flooding. So I told you, right, about constructing the packet source MAC, source IP, destination MAC, destination IP, correct? So in the destination MAC, you have an entry FFF, correct? When you are not aware of your remote MAC address, right? So when you initiate a ping for the first time towards one of the IP 233, so you are not aware of the MAC address, but you are aware of the IP address, correct? So when the switch sees this entry in the destination field of the frame, it's going to flood the packet to every port. Switch has many ports, right? These many ports. So if it receives a frame with FFF packet on the destination MAC address field, then it's going to send the packet to everyone else. So this is called MAC flooding. Sorry, frame flooding, not MAC flooding, frame flooding. Okay.
Yes.
So when you would see FFF on the destination field, when you are not aware of the MAC address of the remote destination, but you are aware of the remote IP. You are not aware of remote MAC, but you are aware of remote IP. So when that condition comes, the switch will put FFFFF on the destination MAC address field. Sorry, the device itself, the host machine, right? The PC. The PC itself put FFFF on the destination field and send that packet to the switch. Upon receiving that packet on a specific port, the switch sees FFF on the destination MAC, then it understands that it has to forward, frame flood to everyone in the system. So that is called frame flooding.
Okay.
Okay. Next thing, if you already have the entry, right, in the entry in the MAC table, right, and the entry is filled, then it is frame switching. So it doesn't have to do send it to everyone else. It just has to particularly forward the packet to a specific port and specific page. So that is called frame switching. When you don't have an entry and the entry is filled with FFFF as a business flag, then it is frame snipping. If you have the actual entry of the MAC address on the specific port, then it is frame switching.
Okay.
And then the next module here is MAC address table. So I just explained you how the MAC address table looks like. And you have the script packet is already open.
Yeah, I'll open it.
No,
It's
you
close.
it will ask you to sign up. Without sign up, see if it wants to open.
No, it doesn't ask me to sign up.
Just share your screen.
Okay.
For me also sometimes it doesn't get.
So I just shared.
Okay, one second. Let me come back to the browser. Can you bring up one switch? Yeah. Double click on it. Go to TLA. You need to put power on, I guess. Sorry, one second. Okay. Go to config. TLA. No, no, there. You see, right? Just above that switch ports, physical config port. Yeah, click on it. Press enter. Enable. Show space Mac. No, no, no. The command show hyphen Mac. Right? Press tab key after Mac. Show Mac. No, no. Show Mac. Remove that hyphen. Show Mac. Tab. Press tab key. Question mark. Shift question mark. Mac address table. Use that one. Mac hyphen address. No, no, no. No, 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 no. Come back. Show Mac. Come back. Remove the show word. Hyphen. No, Mac hyphen address table. Right now there are no entries. So once you connect ports and cables, right, all the ports would be in shutdown state. Show interfaces, show IP, show IP interfaces. They all are in disabled state. So we need to bring up. So once you connect this port on this cable, then you will see entries there. Okay. You can connect one PC. Just connect one PC. First one only. Yeah. There, there. It is up and connected. Now you will show MAC address table. Okay. You connect one more PC. Okay. Give an IP address to this PC. First PC on screen.
How to give that?
Go to config. PC config. Double click. last weekend it came. That is the interface. Okay. So now you give an IP address. Which PC is it, second or first? PC1, first PC. 192.168.1.6. 1.6. Click on the command R. Now you close that.
Oh,
Close it. Okay, first PC.
no, this is PC 0.
Yeah, yeah, okay. This is the first PC. PC0 means first PC. 192.168.1.6. Subnet mask. Now you try to ping 192.168.1.6. Sorry, 1.2. You are in PC0, ping PC0. Ping. Yeah, you see dynamically one IP address learned. So in the Cisco packages, I think it doesn't show the static entries. So it shows the dynamic entries who is connected to. So if you see that MAC address, right, 0007027126, you can check, compare it with the first PC MAC and see if it belongs to that MAC. Repeat once. First PC. SMS. It is setting. Click on settings.
Yeah, and I'm clicking on settings only.
Okay, leave it. Interface. Click on the interface. Yeah. You see the MAC address 0007024134.
Yes, this is the MAC address of the PC first PC.
Correct. So it has learned it dynamically. You see that if you go back to the CLI of the PC, sorry, CLI of the switch, CLI of the switch, you see right dynamic portion, type dynamic in the MAC address. No, no, on the top, show MAC address table command.
Okay. Yeah, here, right?
Correct. You see that right? The MAC address also. See, dynamic.
But did it send any data? We just connected it, right? Did it send any data?
It might have initiated some auto update packet.
Okay.
Since it is a Cisco packet tracer, right? You will see some real life difference between real time and escalation somewhere. So it might take it immediately with some usual patches. But in production environment, you won't see unless you initiate a communication.
Okay. Got it.
Okay. Also, it misses this static entry, right? It only shows the dynamic. It misses static, but in production, you will see the static entry.
Okay.
So let's wind up for the class today. Revise these topics, whatever we discussed. So we can give a break, right? Alternative days, or do you want to have it continuous?
Um, you can have it
Just
alternative.
break for revising. Yeah, just to revise the topic. So
Yeah.
revise it from the starting. Whatever we have covered so far,
Okay.
revise it from the starting. Every break, every alternative day, you take a break, right? So revise it from the top. Again, come from day 0 to day 5, day 6, day 7. Okay, but don't leave the day 0.
Sure.
Okay.
Okay.
Next class we'll have it on Wednesday evening your time.
Sure. All right. Thank you for your class. Bye.
Today is Tuesday, right? One second.
So,
Tuesday.
so today is actually Monday for me. So,
Okay, this is Monday for you. Understood.
yeah.
Wednesday evening.
So also, yeah, yeah. Also, your this thing.